Hey, hello everyone. Welcome to this second session. Today we are going to talk about data sources and data ingestion. Okay. In the first session, we saw the different architectural components. We spoke about the different components like data ingestion, storage, transformations, data consumption, and other set of common services. Today we'll focus mainly on the data sources and how do we do data ingestion from these. What are the different design considerations while doing this? What are the things that you should keep in mind, or what can be the different scenarios? We are going to discuss all these things. So let's try to first understand what are the different types of data sources. Now, data sources can be there can be sources which can send you structured data. There can be sources that are sending you semi-structured or unstructured data also. Structured data is generally sent by systems, right, like the OLTP backends, which are using RDBMS, the typical databases. Most of the corporates had OLTP systems internal systems, I would say, where they used to store all the application data in the backend databases. 20 years back, this was the one of the only source system, this and the file systems, right, like maybe XLS or CSV, from where we used to get this data. Like when I started working as an ETL developer, these were the two main sources or the only sources from where we used to get this data. And in today's modern data world, these are still very very relevant. You will find a lot of source systems that have their backend, that have their data in the RDBMS databases. Then unstructured data. Now this can come from multiple source systems. Like since 2010 onwards, with the rise of Hadoop and all, we saw a lot of social media feeds coming in. It can be Facebook, Twitter tweets, Instagram comments. A lot of things are there, right, these days. So all this is unstructured data. Why do we need these kind of a data? See, while the structured data was mainly meant for your BI kind of a system, the social media and all is required for your AI ML kind of case studies. What can be such case studies, right? Sentiment analysis. Let's say you have launched a product and you want to see the user comments, right? How people are responding to that product, whether they are liking it, or they have some specific feedback about that. All that can be captured through the social media comments. um, Apart from this, there can be a lot of data coming from IoT sensors. Okay, so if you are in an industry, right, where you are dealing with let's say cooling devices and refrigeration, where you have some temperature sensors, and you are checking whether the temperature is below, let's say, 10 degrees or 20 degrees. So you want to constantly monitor that. So these are the sensors that can send you the data at maybe per second basis, per minute, right, depending on what kind of frequency you are. This these sensors would be sending you that kind of data. This is again a very very common use case. um, While we spoke about this, there is also a category, like whether you are getting batch data or real time data from these systems. Like from IoT data, you will be getting some real time data, let's say per second basis, so which you will have to ingest. So based on that, right, what is the source system sending you the data? Based on that, you will have to design your data ingestion. Okay, the data ingestion is driven by two things. What is the source system capable of? Can they send you the real time data? And second, right, see, first is source system, second, what you are trying to achieve, what is your aim? Okay, do you want to do a streaming analytics? If you don't want to do the streaming analytics, it's fine. You even if the source is capable of sending you per second data, you can run it as a micro batch, right? We will talk about it in a minute, about the streaming, micro batches, and all those things. So these are different types of source systems. um, Again, another category, right? It can be, whether the source system is a SaaS application. This is also very very popular and common these days. Like data which is coming from things like, Salesforce or SAP system. So these are the SaaS application, and there are many. It can be, Zoho CRM, um, I think Shopify. A lot of things are there based on, which industry you are working on, what are the applications that your organization is using. Based on that, you will come across this. Now again, dealing with this kind of data, it's bit tricky as in, you can't really connect to its backend database and pull that data, right? So there are specific connectors, there are specific tools in market that can, help you to connect to these systems and get the data, like look for SAP connectors or Salesforce connectors, or all the leading platforms like AWS, Azure. They would be providing whatever the ETL tools are, they would be providing this kind of data to extract data from these systems. Right. So we spoke about structured data, unstructured data, batch data, real-time data, SaaS applications. Okay. In structured data, there are also files. We didn't really discuss that, but it's a very very simple one. There would be files present on, SFTP servers, and from there you have to take the data. Depending on the source system, right, you will have to design your data ingestion system. Now let's talk about data ingestion from these source system. I'm just checking whether we have left out any source, right? Structured, unstructured, batch, real time, SaaS application, IoT, social media. Yeah, I think good enough. One more source I would say, like, your Kafka source systems, like your messaging services. So Kafka is a very very common one. There are source systems which would produce real time data, and they'll send it to Kafka. Kafka is like, it acts as a buffer, so it will be present in the Kafka system. It can retain this data for, 7 days, 14 days. Again, some of the system may keep it for longer. You should be able to take this data from your Kafka messages and then put it into your target system. This is another source system. Sorry about it, like I'm going to and fro, but then these lectures are not really scripted. I've not really practiced it. This is just on the fly, like actual lectures that we do in a class. So yeah, we might keep on going, in we might be going out of tune a bit, but then yeah, I'll try to cover all the important things which are required from a data architecture perspective. The next is, yeah, the data ingestion. So we spoke about these data sources, all the left hand side. Now right hand side is the data ingestion. And right, so the looking at what the source system is, we'll have to design this, and then accordingly we have to select the tools. Now let's say you want to get the data from this. Okay, I'll change the color, from RDBMS system. Now what are the various ways to do that? Now if you want to move data from any, database, now this is the easiest of all, right? Because we have been doing this for the past 20-30 years in the data world. You'll always find, JDBC connectors are there. There are various ETL tools in market that can do that. All the cloud native tools have inbuilt connectors through which you can get the data, right? So connect to this system and start extracting the data. But now see, just connecting is just one part of that, right? You, because we are dealing with big data, right? It's all about OLAP systems, analytics, where we have large volumes of data. We have to see what is the best way to get this data. Now if you are trying to, let's say, move data from a 1 TB table, like, uh, so you cannot just run a Spark job and get this 1 TB, right? You will have to um, create multiple executors and distribute the data, and have a parallel processing of these. So let's say you are using something like AWS Glue, right? Glue is a ETL tool within AWS, right? You are using Glue to connect to this system, the source system, to get this data which is of from a table. Like, let's say a single table is of 1 TB. Let's say you run this with 10 worker nodes. Okay, 10 nodes, 10 executors. So your data should get distributed on that. So when you are writing the Spark script for this, look for the options that can help you to distribute this data on all the executors. You don't want this data going to just one executor. So there are specific properties, when you connect through Spark, or the Spark JDBC connector, right? There would be properties to partition this data. See, if the table is already partitioned, you can do that. But if not, then there are ways to logically distribute this data, right? So look for those kind of properties by which this data gets distributed, right? Only then it makes sense. Else, it will eventually run just with one executor, and it will still take a lot of time. Okay, so especially for bigger tables. So what are the ways? One is, if it is partitioned, you use partition in your where clauses, and maybe monthly. Let's say monthly partition, you can run all the partitions together. Let's say uh, 12 partitions together, 12 executors, one partition on one executor. If it is not partitioned, then there are ways, right? Based on the primary key or surrogate key, you can divide the data and provide the lower bound, upper bound to the Spark JDBC connector, and then move the data, right? So this is one way. Or if you are using tools, other tools, right? ETL tools like Airbyte, Fivetran, you can look for the options, right? So they also, so these are the tools that can provide you a constant replication, right? A real time replication of data. So look for these options also, right? See, what we spoke about from RDBMS, pulling the data is, running this as a batch or micro batches, right? Batch is like just you are running it one time, let's say EOD, end of the day. This was very popular in the initial warehousing days, where we used to run a batch only at the end of the day. Nowadays, right, micro batches, like after every 1 hour you can run this thing. Okay, so you can try that also. But if you want a continuous replication, then look for these tools like Fivetran, Airbyte. They are best for these things. You don't really have to do anything. So these are the options, right? If you want to go through that route where you have to do a low code, no code kind of a thing, you can look for those tools. If you're comfortable writing these scripts in Glue, or for the matter any Spark tool, it is also fine. Other option is to create frameworks, right? A lot of organizations have their accelerators where we create frameworks to extract the data. So if you're working with it depends on your organization, right? If you are working with an SI partner, if they have frameworks, go for that. If you don't have anything such thing, maybe you can create your own custom frameworks, where you build a framework, you just pass in the name of the table name, and yeah, that's it, what is required for the framework to execute and get the data. While this looks fine, we just spoke about getting the whole data here. But what if you want to um, not move the complete data? Let's say you're running these batches on daily basis. On the uh, day one, you have migrated 1 TB of data, right? On day two, additionally, there was point or let's say 20 GB of data was added. Day 3, 40 GB was data added. So you don't want to process all this 1 TB again, right? You don't want to process 1.2 GB here, 1.2 TB here, 1.6 TB here, right? You just want the delta, right? I mean the changes, whatever changes have happened. So this is where things like your CDC come into picture. So look for tools that support this, right? Now, to implement CDC right, it is important to see whether the source system is supporting these kind of things. If they can support the CDC method, right, like whether you can identify the delta, whatever has changed, then you can implement that. What I mean here is, let's say you have a table, let's say customer table, which has ID, address, and a lot of other things, plus a timestamp. Okay, so it in the timestamp column, any new entry or any changes are updated here. So like let's say you have run this till 10th of Jan, right? This was day one. So next day you can get the data from 10th of Jan to 11th of Jan, right? Again between night 12 a.m. to 12 a.m., like that, right? Next day for 12th Jan to 13th Jan, again you can pull that based on the timestamp. So this becomes the CDC column, or it is also called as watermarking column, right? Watermark column. So you can use that. So it is important to identify. If you don't have such column, right, it is going to be a problem. Okay, because then you don't want to, you know, move the whole data. Now this mechanism where you move the whole data is called as the whole snapshot data. You are taking the snapshot. While this approach is like CDC, it is the incremental data processing. Again, there are different tools available in market. You can explore Kafka, DBZM for this, or AWS DMS, data migration service, also offers incremental replication. But then there are certain things that you should look at as an architect, right? See, most of the times these system RDBMS are the backends of an OLTP system. So those system, what happens when you're trying to get this data from them, the performance gets hit of that system, right? And these are these are the actual source systems, right, where users are logging into this and doing some activities, right? These are mission critical. You cannot if there is a performance issue there, it can be a problem at the customer end, okay, because these are customer facing apps. So they don't really allow you to run a lot of JDBC connections here. We spoke about running 20 connections here and all, but the admins here may not allow you to do that. That is one thing. Second, on the CDC tools, right? Let's say AWS DMS, what it does, it reads the redo logs. Okay, redo logs from this database systems, right? And that is how you get the transactions and the changes. Again, some of the admins DBS may not allow you to do this, okay, because it hampers the performance of the system. So you should be aware of this. You cannot just recommend, okay, let me use AWS DMS and move this data. You have to check with the source system. If they allow it only, then you can do that. If not, you have to look for the other options, right? So always read the document. See, I don't want to talk about the tools, right? Because there are multiple tools in market. I have not studied all of them, but whatever I have seen, things have changed again now, right? Every 6 months things changes. um, Always and always, right, read the docs. This is very important before you suggest any design or any tool, and see how it is doing that, right? It's okay if a tool is moving the data, getting the incremental data. Try to understand how it is doing that, and then see if there are any constraints at the source side. If there are any constraints, then you won't be able to do it, okay? uh, so yeah, please keep that in mind. So this was all about moving the data from RDBMS systems. By the way, I'm giving away $20 credits for AWS. If you plan to implement any of these using AWS services, please ping me on LinkedIn and I'll give you the credit codes so that you can try them out.